IEEE Delhi section, Industry Relations and Site Standing Committee of IEEE Delhi section, with the Associations of Computer Society of India, SAFA Society, ISTE Delhi section, and IETE Delhi Center, welcomes you all to this webinar on role of computational reasoning for effective research. G.M. Weinberg stated that Newton was a genius, but not because of the superior computational power of his brain. Newton's genius was, on the contrary, his ability to simplify, idealize, and streamline the world so that it became, in some measures, tractable to the brains of perfectly ordinary men. This quote indicates the importance of computational reasoning for effective research in the present times. Over a number of previous decades, there has been tremendous development of computing resources useful for academic and also for research purposes. Howsoever, so far these resources cannot substitute the human superiority regarding capabilities including creativity, common sense, judgment, visual understanding, and finding principles behind different phenomena. The computer is superior for research purpose when the problem under consideration is well defined, knowledgeable of the problem domain is perfect or nearly perfect, and the reasoning required can be easily formalized. On the other hand, if the problem is not well defined and or the knowledge of the problem domain is imperfect, that is, it is incomplete, ambiguous, fuzzy, imprecise, inconsistent, etc., and the reasoning required is based on common sense judgment, visual reasoning, etc., then human intervention is essentially required. Thus, in order to optimally utilize man-machine resources for research, it is essential to know the type of problem, nature of the knowledge of problem domain, and the types of required reasoning. This webinar today aims to explore this role of knowledge and reasoning for obtaining optimal solutions and for avoiding hazards and disasters, etc., caused due to negligence. But I would first take this opportunity to welcome amongst us our distinguished panelist for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor Subrata Mukhopadhyay, Chairperson, Consultants Network Affinity, CNA Group, and former Chairperson, IEEE Delhi Section. I would now request Sir to commence the session with his welcome address.
Dr. Ritika Vasan, should I speak or Professor Mukhopadhyay will speak?
Sir, Professor Subrata will right now give his welcome address. Then after
okay, I will not take much time.
Welcome
to everybody.
I'm sorry for the intervention.
Panelists as well as the other attendees from India as well as abroad, I'm sure. Role of computational reasoning for effective research by Professor Manohar Lal, former director of IGNOU. Of course, I'm well connected with his works and the versions because wherever he goes on giving lecture, I get a copy also. So I'm indeed grateful to him. Today's topic, again, like that disruption in technology, it is creating a lot of inquisitiveness from the people. And Ritika has told already a lot about the effective research, computational reasoning, or whatever there is in common sense in our science and technology applications. There must be some positive and negative effects also on these things, because earlier people used to escape with doing some other types of research, but not being traced. But nowadays, I mean, even if you manage to do something not in a proper way, can be easily detected. So research, definitely it is aiding whatever the reasoning is there through computation, and artificial intelligence is also coming in a big way. So we have to be cautious, and definitely something worth to be given back to the society or mankind should be the motive of this type of research. With this word, I am again welcoming everybody who is present over here. I could see 137 participants growing up gradually. Let me hand over to Ritika.
Thank you so much, sir. I would now request Professor M.N. Huda, sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management, to address the participants with his inspiring words.
Good evening, one and all. Subrata sir, Murthy, my friend, and the chairperson of Industry Relations, Mr. Ajay Goel. All of us together welcome today our valued speaker and a very elder person from our community academic fraternity, Professor Manohar Lal ji. My dear friends, I also take this opportunity to welcome you all participants from different parts of the country and abroad who keep on waiting for this webinar, weekly evening webinar series of Delhi section and BBI Camp. This is 58th webinar of this series. For about today's topic, role of computational reasoning for effective research. The topic has well been introduced by Dr. Ritika Vasan, the perfect host, my team member, my colleague at Bharati Vidyapeeth. And what about the speaker, Professor Manohar Lalji? Almost last 2 decades we are connected for a variety of academic purposes, and I can only say that he is such a passionate learner that I can't explain his passion with which he continues and still to learn. Is a matter of great inspiration for all of us. Passion with such dedication, with such commitment, that he even never stops after achieving his destination, after achieving his result. And he keeps on exploring it further. And that's how he keeps on always preparing a new topic. And I have today only requested to him that let's prepare and deliver a webinar on digital humanities, to which he has readily accepted, because digital humanities is going to come up as a big domain intersecting almost all possible spectrum of human life and day-to-day educational system. So he's such a passionate learner. Passion, all of you know, and to me passion is very important in terms of the Bashir Badr language. Bashir Badr ने हमेशा passion को ये समझाने की कोशिश की है कि passionate लोग अपना destination, अपना result मिलने के बाद भी जो जुनून है, उस जुनून में आगे इतना बढ़ चुके होते हैं कि बहुत देर के बाद उन्हें समझ में आता है कि जो मेरा माइलस्टोन था वो तो कब का मैं अचीव कर चुका, and I have come far ahead of that kind of passionate Professor Manohar Lal is. So with this 4 lines of Bashir Badr, we want to welcome him, that आंखों में रहा दिल में उतर कर नहीं देखा. ऑन द फ्लाई चीजें अलग होती हैं, लेकिन आपको अगर गहराई तक जाना है तो उसके लिए सब्जेक्ट के डेप्थ पे जाना पड़ेगा. आप वेबिनार के बाद समझ में आएगा प्रोफेसर मनोहर लाल जी किस डेप्थ तक बात करते हैं और कितने पैशन से अपने सब्जेक्ट को आगे बढ़ाते हैं. कि आंखों में रहा दिल में उतर कर नहीं देखा, कश्ती के मुसाफिर ने समंदर नहीं देखा. इतना बढ़िया बैकग्राउंड सीन है मेरे फ्रेंड अजय गोयल जी का कि वो समंदर याद आ रहा. कश्ती में रहा समंदर नहीं देखा, तो कश्ती के मुसाफिर को समंदर का क्या पता. समंदर की तह तक अगर पल्स देखना है, सब्जेक्ट का डेप्थ देखना है, तो टाइटैनिक जैसा शिप का शायद सहारा लेना पड़ेगा. सो आंखों में रहा दिल में उतर कर नहीं देखा, कश्ती के मुसाफिर ने समंदर नहीं देखा, जब से चला हूं मंजिल पे नजर है, राह में कभी मुड़कर मील का पत्थर नहीं देखा. ऐसे पैशन के साथ मनोहर लाल जी अपना काम बढ़ाते हैं और इस एज में अपने सुपर अन्वेषण के बाद भी अपने सब्जेक्ट मैटर को आगे बढ़ाते हैं. मैं इन 2 पंक्तियों के साथ उनको वेलकम करता हूं कि चले भी आओ कि गुरों में रंग भरे बाद बहार चले, चले भी आओ कि गुलशन का कारोबार चले. थैंक यू सो मच, and I express my gratitude to all my friends from different collaborating societies who keep on extending their collaboration, under which this webinar, weekly evening webinar series is being organized. Thank you so much. Over to you, Dr. Ritika.
Thank you, sir. I would now welcome amongst us our expert speaker for today, Professor Manohar Lal, Director, School of Information, Computer and Information Sciences, IGNOU, New Delhi. Professor Lal has teaching and research experience of over 50 years, having taught at various universities like University of Delhi, Jawaharlal Nehru University, and South Asian University. From the year 2000 to 2012, he was director at School of Computer and Information Sciences, Indira Gandhi National Open University, New Delhi. Earlier, he has also served as professor and head of Computer Science Department and Director, Computer Center at MD University, Rohtak, and at HP University, Shimla. A product from IIT Kanpur, IIT Delhi, and University of Delhi. He completed his MTech in Computer Science and Engineering from IIT Kanpur and pursued his second PhD in Computer Science and Engineering from IIT Delhi. Earlier, he completed his master's and PhD program in mathematics from University of Delhi. Sir has even visited the North Carolina State University for his postdoctoral work. He has delivered more than 600 hours of lectures through educational channels, including EduSat and Gyan Darshan of TV and Gyanvani of radio. Professor Lal also has a long coveted research experience. He has worked in the area of error correcting codes. Currently, he is working in the areas of theoretical computer sciences, formal methods in software engineering, and automation of reasoning. He is a member of numerous international and national academic and professional bodies. He is a reviewer for a number of national and international journals in mathematics, artificial intelligence, and e-learning. I welcome you today to this session, sir, and I would now request you to enlighten the House. Manoj?
Thank you.
Yes, sir.
Thank you, Dr. Watson. I'm really grateful to you and Professor Mukhopadhyay, Professor Hoda, Professor Subramaniam, Professor Goyal, and others for remembering me on this occasion. Professor Hoda has given floral, so many things he has said about me and yourself also. Actually, Professor Hoda is a friend, and he may say many things exaggerated also. But anyway, it feels good even at this age of 76 to listen to such things and all that. I'm also thankful to the various institutions which are involved in this one, and particularly IETE, Bharatiya Vidyapeeth, IEEE, and Computer Society of India. I feel really honored for this one. Also, I am thankful to the faculty, officials, and members of these esteemed institutions, especially Mr. Uttam Singh, who is helping me from time to time in technical matters. Also, it gives me opportunity of interacting with scholars from across the country and even from other countries. I am therefore grateful to the scholar participants who have kindly spared their valuable time for this webinar. Last but not least, I'm thankful to my granddaughter Sarvagya, who has taught me how to use the link in the beginning of the lecture. So with this, friends, a few words about the style of my lecture. Actually, the audience being from various disciplines and of different levels, from undergraduates to postgraduate and faculties and all that on one hand, and from various disciplines, possibly from humanities, sciences, and technical subjects. Therefore, I have prepared this lecture from the very elementary level to the research level. The second thing which I wish to say is that despite the fact that technology provides a lot of very good interactive facilities, still the eye-to-eye contact is not possible. And in view of that, most of the things which I want to say, I've said, and therefore little explanation will be required. So with these two comments, with your permission, I'll start with the lecture. As Dr. Watson has already told, that the topic is role of computational research for computational reasoning for effective research, and she has also outlined the most of the things of the topic. Friends, first of all, you'll give me time to adjust the screen. If can I? Oh, okay. Please, you'll excuse me for 1 minute.
Sure, sir.
But the slide is not. Oh, okay. So, friends, the topics which will be discussed are, first of all, conceptual framework. Then the second part is why computational. The third part is how computational. Fourth part is salient aspects of academic computational linkages, followed by conclusion and references. So friends, we start with the conceptual framework, the various terms which are occurring in the title, for example, reasoning, research, or computational means. So we'll start with the brief explanation or touching each of these concepts before going in details. So friends, research, as per Zora Neale, a well-known author, American author, around the 20th century beginning, she says that research is formalized curiosity. Is poking and prying with a purpose. Formalized curiosity means that you are curious, but you formalize it in the form of rules, regulations, how to structure and all that. So it is a formalized curiosity. For our purpose, it will be enough. Then, of course, the great Einstein says, if we knew what we were doing, it would not be called research, would it? Anyway, the comment is there for us to refresh our memory of that great man. Friends, research is conducted, including for solving some unsolved problems, answering some so far not satisfactorily answered questions. Easy, what is intelligence? Especially in view of that now machine is capable of intelligent behavior. Attempting to answer new types of questions. What is human fate vis-a-vis rising power of machine? Proposing new techniques, methods, strategies which help in solving a type of problems or some hitherto unsolved problems. Continuing, proposing some simpler new theory or model of phenomena. Easy unifying theories, easy of Copernicus about motions of celestial bodies and Galileo's about motions of terrestrial bodies by Newton. Actually, Newton combined that or unified the two theories of Copernicus and Galileo by giving a simplified, unified theorem. So it is a great research. And then if we come to other discipline, Kenneth Arrow, economist, general impossibility theorem, and Amrita Sen's theory of economic development, and Herbert Simmons, very well-known figure who won both the Turing Award and Nobel Prize. He is the only person in the world so far who has won both of these prizes, Herbert Simmons' decision-making theory, satisfier theory. Hence, this way we remember the quotations of the great people who have made significant contributions to our life and to intellectual pursuits also. So here, Galileo says in questions of science, the authority of thousands is not worth the humble reasoning of a single individual. Reasoning. Now I'm taking the second concept. First we discuss briefly research. Now we are discussing reasoning. Reasoning is the intellectual process conducted by man or machine, which helps in reaching explicating useful but implicit facts. That is, by reasoning, though the fact is already there, but it is not explicitly known. And through reasoning, we explicate the implicit fact which is otherwise useful. Thus, friends, reasoning is the intellectual process conducted by man or machine which helps us in explicating useful but implicit facts. Computational means, next term. The term arises in view of the fact that the human beings and computer systems have some different fundamental characteristics for solving problems. In view of the mutually differing characteristics, the two problem-solving systems have to have different means for solving problems. Where we use the term means for intellectual assets, consisting of tools, techniques, methods, approaches, styles, rules, principles, and even laws. Friends, just in brief, I may mention that the computer's main strength is computational speed and large storage capacity, which I'll discuss little briefly further also. But in order to explain the difference between human way of problem solving and the machine's way of problem solving, I just explain how the machine adds 8 to 5. You'll be surprised that it is too simplistic a approach of adding 8 to 5. The machine will first convert 8 to binary, 1, 0, 0, 0. And then it will convert 5 to binary, that is 0, 1, 0, 1. And then one bit at a time it adds. That is what we mean is to say that even a child may be doing it much faster in lesser number of steps, but the machine does. But despite its simplistic approach of solving problems, the machine can add millions of numbers of million digits in a fraction of a minute. What is the reason? The reason is computational speed. Friends, next part is why computation at last. Friends, computational resources have many advantages. First of all, it is miniaturization or minuscule storage requirement. Speed of calculation, petaflops per second, and hence number 3, copyability, and number 4, availability of information with a click of a button. We go a little bit in details. Miniaturization. Friends, on the right hand side, there is a pen drive, middle. It weighs less than 30 grams with physical dimensions of 1 centimeter, 1 cross 2 cross 6 about, or even less. With information storage capacity of 64 gigabytes. You can see 64 followed by 9 zeros to terabytes. That is 1 followed by 12 zeros. On the average 7 characters may word that it can be store 64,000 books of 200 pages each. And it barely costs rupees 400. This is the one reasons because of which the computational resources are used. The second, which is a rather more important fact about the computational resources, why we use this. Well, friends, speed of calculation is very fast, as just now I mentioned, despite its very simplistic approach of adding numbers. It can add millions of numbers of million digits each in a fraction of a minute or second. Millions of numbers each can be added in a, technically speaking, supercomputing is measured in floating point operations per second, petaflop, are the measures of computers processing speed equal to, you can see, 1 followed by 15 zeros in 1 second. These capabilities of cyber resources are based on the fact that all objects are stored as electronically, optically, and operate at electronic optical speed of 3 lakh kilometers per second. So friends, these are the two major reasons or advantage of machine, because of the machine resources or computational resources are used, and as a consequence, friends, the later one, speed, I mentioned, it is fantastic as compared to the human capability of computation. Friends, this speed is money, and not only money, billions of dollars of money. Just an advantage of milliseconds in speed made this man, Pitraffi, billionaire. And for this, if you want to go into the details of this story, you read this book, Automate This, by Christopher Steiner, Penguin 2012. Pitraffi, the pioneer in this respect, who exploited the speed of computation in the share market. He was born in 1944, is a Hungarian-born American billionaire businessman, migrated to USA in 1965, excuse me, with less than $100 in pocket. But what was his advantage or whatever was the secret that he said that millisecond advantage in declaring the share prices or knowing the share prices can make you billionaires. So speed is money, and not only money, but billions of dollars. Other advantages of the machine, which I said, copyability and modifiability. Copies of any document, even in thousands, can be produced in no time. Any document for modification has not to be scrapped or required to be completely written, can be modified very easily as compared to the earlier. Earlier, when we used to write on paper, the paper has to be thrown and rewritten. Software developed once can be copied, uploaded on thousands of machines in no time. In general, any cyber report can be duplicated in thousands without much effort. This is another reason for computational resources being used nowadays in almost every walk of life. Friends, another, just to summarize the advantages, what applications have been achieved in brief. You have mobile phones providing anytime, anywhere connectivity, availability of knowledge, as I mentioned, medical expertise in respect of diagnosis, treatment, and even telemedicine and telesurgery, reducing thereby the requirement of experts' availability at every place to the bare minimum, and increasing life expectancy and quality of life manifold. Weather forecasting nowadays is really reliable. Disaster forecasting saves thousands of lives. Friends, these are some of the reasons why computational resources are used nowadays in everyday life and even research and education also. With this, we pass on to the part three, how computational. We mentioned the advantages, but how, just briefly, we'll discuss how this computational capability is to be achieved. Hence, brute force computing speed and storage capability by themselves don't make computers powerful tools. Please be careful. It is not merely the speed. Computational problem solving is not straightforward translation of human problem solving. Man and machine have different inherent intellectual assets, and hence or otherwise have different styles for solving problems. And therefore, friends, not taking into consideration the differences in intellectual styles of solving problems may lead to disasters, as is explained by a few of the next slides. Friends, because of neglecting the special characteristics of machine for solving problems, some of very serious disasters happened. I quote here just four. On February 25, 1991, during the Gulf War, an American Patriot missile battery in Saudi Arabia failed to intercept an incoming Iraqi Scud missile. This Scud struck an American army, its own people, and killed 28 soldiers. The cause of the failure to be discussed was only minor oversight of the fundamentals of problem solving using machines. Machines don't solve the problems the way human beings do. This fact I repeatedly say and must be taken care while solving problems with the help of the computer. Another one, explosion of Ariane 5. On June 4, 1996, an unmanned Ariane 5 rocket launched by European Space Agency exploded just 40 seconds after liftoff. The rocket was developed over a period of 1 decade, costing $7 billion. Similar reason, neglecting the characteristics of the computer in solving problems. Third is similar ones. An offshore platform also failed, which cost about $700 million. Rounding errors in an election. A shattering computer error was experienced during a German election. Regarding the elections to the Parliament for the state of Schleswig-Holstein, in which the actual winner was shown by computer system to be getting least number of votes. It shows that we have to use the computation resources very carefully. Otherwise, the results may be just totally opposite of what actuality is there. Friends, now I come to what were the reasons. Friends, the reasons were oversight of the fundamentals of use of computer tools, which I am repeatedly saying so far. Of the types including easy. For example, just through an example, I explained the type of errors which are committed in these particular cases. The landing distance of the Mars is about this much, 220 million kilometers, but here it is precisely decimal 3342. However, because of oversight or constraints of the computer, the last two digits were missed in calculation. And when it was executed millions of times, the rocket intended to land at a very, very far off place. So this type of errors has to be taken care of. This is just a glimpse. In such a short lecture, we can't go into the details, the type of errors which may, or type of mistakes which we human beings may commit while using computational resources. So friends, apart from the reasons why such serious mistakes or blunders occur, developing the use of computational tools. Well, friends, software domains are much more complex than the roads for cars. Also, software is inherently much more fragile as compared to mechanical and electronic devices. Eiffel Tower has 2.5 million nuts and bolts. If even hundreds of nuts and bolts are removed, there may be hardly any damage to the tower. However, an average software contains millions of lines. And even if a single comma or other character is removed, whole software is generally completely damaged, or at least it malfunctions. So friends, you can see software is very fragile. Even a single character may completely damage it. There is need for much more caution, particularly for critical applications, including research, while drawing inferences from the information data obtained through computational means. I am repeatedly saying the computation resources have to be used very, very carefully. Steps to solve problems computationally. Well, there are some principles of solving problems with the computational tools. I'll go into the details of that so that this type of mistakes are not repeated. Friends, we'll discuss 5 principles. Use appropriate man-machine strengths, which I will go into the details. Use appropriate representation. Find and use the type of the problem. Find and use the appropriate type of knowledge. Use the appropriate type of reasoning. At least these are just 5 principles which I am saying here out of hundreds, but these are very important ones. Principle 1. Man and machine have, as I mentioned earlier, also relative merits and strengths, as discussed in the next slides. Use computer resources only for solving those parts of the given problem for which it has strengths vis-a-vis man. Dr. Ritika Vasan also mentioned many of such things. Well, first of all, we go through in what respect the computers are better than human beings, and in these respects we should use the computational tools. One is numerical computation, then repetitive tasks. If the salary of thousands or lakhs of employees is to be calculated, the process is almost same. However, a human being get bored or even get tired, but the machine doesn't get tired. Then information storage, I have already told you the thousands of books can be stored in a small pen drive. Instant acquisition of tools, hence instant, as I mentioned, that a software can be copied on thousands of machines in a very small time. So these are some of the advantages that which a machine has. And whenever our task requires any of this type of, then we should use these ones. All these advantages of computer arise from the fact, as I have already mentioned, because it works at the information is stored electronically or optically, and these work at the speed of light. Oh, friends, still, I don't know about the near future, but so far, the human beings have these advantages over the machine, though these are being taken over by the machine gradually, and we don't know in the future even these human advantages will remain or not. But so far, these are the advantages. And if a problem involves this type of task or subtask, then we should use the human intellectual assets instead of the machine. First of all, understanding of and reasoning with natural language is both spoken and written. Because the problems occur to human beings. And human beings explain the problems in natural languages, think of in the natural language, explain in the natural language, and only that natural language problem is then converted to machine language and all that. But we are really still much, much better than the machine. Millions of common sense facts, friends. This is the most important human asset, which is generally neglected. We'll go through it into details. Then use of judgment, I'll explain everyone. Learning, that is acquiring new knowledge, creativity, strategy making, abstraction or finding principles behind various phenomena, and vision understanding. These are the areas in which human beings have little problems, in which even a 5-year-old child may surpass a supercomputer. Hence, these areas form subject matter of artificial intelligence. One of the definitions of artificial intelligence is the study of those areas in which so far the human beings are better than machine. So these constitute the subject matter of artificial intelligence also. The machine is gradually improving and in some cases surpassing man in some of these areas, but still the human beings have these advantages. The above human advantages are explained through some examples. Reasons I just now mentioned. One of the biggest human assets is creativity. And in all these cases, whosoever have written these or considered this, these are really acts of creativity just to create humor, make meaning life more interesting. For example, our salesman can sell tickets to hell in such a way that you look forward to the trip to go to hell. This is a humorous, but to generate humor, it requires creativity. Don't argue with an idiot. He will drag you down to his level and then beat you with his experience of being idiotic. Light travels faster than sound. This is why some people appear bright until you hear them speak. To steal ideas from one person is plagiarism. To steal from many is research. What was the purpose of these humorous statements? Is creativity. Human beings are very good in creation, such many things, even in the intellectual or even scientific and technological areas. Also, these are just examples. Now you say, somebody created this also just to make the life more interesting. According to the time of pandemic, what is the difference between paneer masala and paneer tikka masala? Second one is vaccinated. Next, now you see, again, human creativity, I'm asking. A student who got 0% marks was surprised because his answers are seemingly correct. Question, In which battle did Tipu Sultan die? In his last battle. Question: where are the declarations of independence signed? At the bottom of the page. What is the main reason for divorce? Marriage. Of course, if people are not married, they will not divorce. Ganga flows in which state? Liquid state. Friends, purpose is to think of this leads to human creativity. The answers are in some sense correct, but answers are not according to expectations. Friends, I must tell you, the human expectation plays a very, very significant role in the human progress throughout the ages. So expectation is very, very important feature of the human beings. You'll bear with me about this humorous some things. Now, this is again a case of create. So anyway, this is how creative people, this was just in lighter vein, but in real life also, our creativity is creating a lot of wonders in scientific and technological domains also. We can't go into the details of those. Now, friends, another big asset which we human beings have, the common sense. All these instances of creativity, human common sense and natural language capabilities are involved. And embedding common sense in machine is one of the toughest challenges for computer scientists. I repeat, and I go into the details also. One of our biggest assets is common sense. I'll illustrate it through some examples. But before that, let us know what is common sense. It is acquired mostly unconsciously, used both unconsciously and consciously. Most of it is acquired unconsciously through interaction with the world around. It forms a very large part of human knowledge. This implicit knowledge has to be explicated for embedded in the machine, for being embedded. Friends, complexity of embedding common sense is machine. First of all, I give a few examples in order to illustrate it further. I'm emphasizing the common sense asset of human beings, which is really a big asset in our progress, which is so far is not acquired by the machine. Some of the examples of common sense are: a person dead once is dead forever. In no book it is written. We just know through our implicitly. A person cannot die before death, birth. A part of something or somebody is also located where the body is located. A stone is not hurt when hit, but a dog is hurt when hit. Millions of such common sense facts are embedded in our psyche, and we use these without our being aware. Though these are seemingly simple facts, which even a child knows, yet each of these plays significant role in solving problems which even a supercomputer may find difficult. Just for the sake of illustration, I take the third, which is highlighted. A part of something or somebody is also located where the body is located. In no book it is written, but we know, everybody knows. But the computer has to be told it explicitly, and how it is used by us in solving problems. Let us have an example. Here is an example how we use that. Well, myself, I talked to Dr. Robert. I've seriously injured my right leg. Please help me. I am delivering an invited talk from my room at such a place in Delhi. Dr. Robert, but sir, where is your right leg, which is injured and needs to be treated? It is not at all uncommon if a computer asks like this one, because computer has to be explicitly told that all the parts of the body are there, where the whole is there. And we use such facts, millions of such facts in solving everyday, not only everyday problem, but scientific and technological problems also. Friends, to sum up the significance of common sense and the difficulty of embedding in the machine, a project was started, CBYC, which is shorthand of encyclopedia, in 1984 by Douglas Leonard and Ramanath Guha. And its first stable release was obtained on 27th November 2017, you can say 33 years afterwards. And still it is not satisfactory. Even in the beginning, the topmost laureates at that time, computer scientists, have said that it will take very, very long time. Even before the CBYC project, Psych project began, in order to estimate the complexity and time to be taken by the project, a conference in 1983 was held. Calculations by some of the pioneers of AI, including Marvin Minsky, Alan Neville, Edward Feigenbaum, and John McCarthy, estimated that the effort would require 1,000 to 3,000 years of effort. What I wanted to convey to you, friends, our common sense is a big asset vis-a-vis the machine, and we must use whenever it is required in solving problems instead of using the machine. Next advantage of the human beings is finding principles. Friends, we cannot fly, but can make machines that fly by knowing principles of flying. We cannot see beyond some 100 meters, but can make telescopes locating objects millions of miles away through microscope. But how? By knowing and using principles of optics. Can't move fast, but can build vehicles by knowing principles of locomotion. We are so far better than machine in finding principles and using these along with appropriate material to get the machine that flies. This is another advantage which the human beings have over the machine, but only so far. Friends, but again, how we find principles? And this is really very risky question. Because once we know the mechanisms, then we embed in the machine and the machine beat us by its speed. Example, falling of apple leads Newton to think of gravitation. He could not have explained the mental mechanisms by which it struck him. Paradoxically or ironically, as I've already explained, once we know the how, what are the mechanisms by which we find the principles, we embed the principle finding capability in the machine, and machine beats us because of its inherent speed. Anyway, that is another thing. Friends, another aspect in which we human beings are very good vis-a-vis the machine, that is judgment. On a crowded road in a city like Delhi, crossing it is quite difficult and risky, but still, for safe crossing, nobody uses the formula S is equal to UT plus half it square for each of the vehicles to reach him or her and avoiding them across the road. We just cross the road on the basis of judgment. Judgment, what is judgment? Conclusions or decisions arrived at by not going through complete systematic conscious efforts or calculations. Once again, judgment is the making decisions or conclusions by not going through complete systematic conscious efforts. Machine does everything through conscious calculations. Human beings still do or pass the machine in the matters which involve judgment. So these are some of our characteristics in which we are much better, and this picture itself explains that we are still better than the machine. The machine in this particular case has to be explicitly told that cutting the branch may lead to harmful consequences. So I enumerated number of human characteristics in which human beings are much better than the machine. I also enumerated some of the characteristics of machine, particularly the speed. And in view of the enumerations, therefore, for solving difficult problems, appropriate man-machine combination is essential, where the human creativity, literal thinking, judgment, learning, strategy making, natural common sense should be used if the part of the problem solving requires this. But on the other hand, if the speed is required, then the machine is much better than the human beings, and therefore we should use this one. Friends, this was the first principle. What was the first principle? That the man-machine have relative strengths, and those should be appropriately used. The second principle of using machine properly for solving problems is appropriate representation. I just illustrate the things through examples, simple examples. For solving problems using computers, appropriate representation of data plays a significant role. For example, consider computing the product 67 multiplied by 41. Friends, if the representation is used Roman numeral, as was done up to even 15th or 16th century in Europe, then you'll be writing it as L followed by X, etc., etc. And if one attempts to solve the problem of product just using Roman numerals, it is quite difficult or almost impossible to solve the problem even in 2 days by the experts. However, once it is represented in decimal number system, then it is a child's play. What this example explains, that whenever we are attempting to solve a particular problem, we must find the most appropriate representation. It is not just to carry out our thinking into the machine. Appropriate representation plays a very important role. Friends, I may repeat again. Till the 16th, at least 15th century, in Rome, in Europe, the Roman numerals were used. And finding out the product was so difficult that the people used to go to a place called Sorbonne near Paris to get their simple problems of the product to be solved. So you can see that appropriate representation facilitates the solution of the problem to a large extent in many cases. Friends, we have talked of two principles earlier. The third principle, find the type of the problem. Because depending upon the type of the problem, the computational means to be used have to be decided. So in this respect, I'll go into the type of problems which we may encounter. So first of all, types of the problems include, and starting from the most difficult type of problems which we human beings may encounter and have been encountering in the past also. Problems not even recognizable. So friends, there are various types of problems and for which the computational resources should be used. I just want to explain this. First of all, the most difficult type of problems are those which are not even recognizable. For example, all possible negative consequences of new technology. For example, in the initial stages of IT revolution in mid-20th century, nobody could guess the serious danger from fake news and cyber crimes though the problem started breeding insidiously with adverse consequences becoming visible too late. Similarly, when the first automobiles started flying on the roads around the end of 19th century or beginning of 20th century, nobody expected these harbinger of severe pollution. So friends, the most difficult problems which we encounter are those which are not even recognizable. Something happened. Okay. In the second one, the problems are recognizable, but not definable. why the economy is not doing well. Well, we know the problem is there, but we are not able to define it because computer will solve the problem only when it is defined. What are the symptoms? What are the parameters? Why there is hunger, illiteracy, and suffering despite international efforts to eradicate these? For computational definition of a problem, we need to enumerate all the various inputs and output parameters used in calling the economy unwell, but we can't. Also, we need to tell for what values of these parameters the economy can be said to be well or unwell. Well, it requires a definition in order to solve the problem. These parameters must be defined. Then the third category of problems is definable but not solvable by computational algorithmic means. For example, it is well-known problem in computer science, the theory of computer science, finding the exact roots of general equation. Even in mathematics, it is not. There is no general method or algorithmic method of solving a general equation of degree of 5 or more, halting problems. And is the statement I'm telling lies true or false, which is called liar's paradox. These problems are definable, but we can't tell. We can't solve by systematic step-by-step method. So friends, we have enumerated 3 types: not recognizable, recognizable but not definable, definable but not solvable. And the 4th is solvable but not feasible. What does this mean? That it may take too much time, that by the time the solution comes, the solution becomes useless. And some of the well-known problems in theory of computer science are traveling salesman, factorization problem, crossing the road, etc. Most of the real life problems fall under any of these categories, the earlier 4 ones, in which exact solutions are generally not possible. Of course, acceptable solutions are there. In case of the last 2 categories, it has been discovered in the earlier stages of computational problem solving that the knowledge of nature, domain, and environment of the problem may help in solving such difficult, unsolvable problems, generally not exactly, but acceptable. Now, friends, we come to the here. Out of these problems, which are solvable but not feasible, some of the problems can be solved exactly by human intervention. Consider the problem of finding out the roots of 2x raised to the power 6 plus 3x raised to the power cube plus 1 is equal to 0. It is a 6-degree equation. And for 6-degree equation, there are no algorithmic solutions. However, friends, the human being can recognize that is the artificially 6-degree equation, but actually it is 2nd-degree equation by replacing x cubed by y. So in such cases, there are many problems which may apparently be unsolvable, but may become solvable through the human capabilities of judgment, which I explained earlier. Then the last one, friends, of course, is that one, which is feasible problems. That is the problems which can be solved with computational means. Not only can be solved with computational means, but also in reasonable amount of time. And the whole industry is about this one. However, other types mentioned above the problem can be solved and solutions attempted, but those solutions must be non-algorithmic. And this is where the artificial intelligence comes, which uses non-algorithmic methods for solving difficult problems. However, the solutions will not be or generally are not exact, but only approximate ones. Friends, so I told you before using computational means kind of the type of the problem and appropriately use the computational resources or human resources as are required only for feasible problems. The computational resources are most appropriate For others, in part, they may be useful or may be helpful. Now we come to the next principle and the type of the knowledge. Before attempting to apply computational means, so I'm explaining various principles which can be quite useful in solving the problems appropriately by computational means. Otherwise, it may lead to disasters which I mentioned earlier. Now, this is significant in view of the fact that knowledge is hardly perfect. Most of the time, our knowledge is imperfect. There are various types of possible imperfections in our knowledge, and different type of imperfections require different computational tools, and therefore it is very important to know what type of imperfection is there in our knowledge. Friends, knowledge is said to be imperfect if it is either uncertain, incomplete, vague, imprecise, ambiguous, inconsistent. Well, these are various types, and these may constitute a lecture by themselves. So here we briefly go that what may be the type of imperfections in our knowledge and what are the models which may be useful in each of these cases. First of all, knowledge is imperfect because of randomness in nature. Randomness means group deterministic but individual non-deterministic. It is said to be, for example, the number of children that will be born in a particular period, so that the medical arrangement or the hospitalization facilities, etc., may be available. Even how many people may fall ill in the pandemic, nobody can know it, so that we prepare in advance. Number of persons falling ill, of course, is there. Even simple activities like tossing a coin or throwing a dice are not known in advance. Outcome of toss of a coin is group determined. That is, we know the result will be either head or tail, but which one of these two, nobody knows. Motion of an electron in an atom is also random. So friends, one type of imperfection in knowledge is randomness. And to handle randomness, one of the most appropriate tools which have been found so far is probabilistic means or statistical methods, etc. Now, the second type of imperfection in knowledge is fuzziness. Fuzzy is something like this, that you can't tell when a young man becomes old or when spring becomes winter. The adjective young has nature of changing continuously and subtly, with no clear-cut boundaries to distinguish it from the old. Similarly for spring. And for this, the mathematical model is a fuzzy theory which handles this appropriately. What I mean to say, fuzzy theory cannot be applied in random phenomena type of imperfection, and similarly statistical methods cannot be used, or probabilistic methods cannot be used when the imperfectness is fuzzy. Friends, the third type of imperfection or blemish in our knowledge may be ambiguous, and it requires its own type of tools. For example, what is ambiguous? Dinosaurs ruled the earth for a long time, about 1,000,000 years. It has not rained for a long period, say about 6 months. I had to wait for the doctor for a long time, at most about 60 hours. Friends, you can see the phrase "for a long period" stands for millions of years to months and hours. It is ambiguous for which particular it stands, that is resolved by the context. So when the context resolves the uncertainty, then it is called ambiguous knowledge, and it requires its own type of tools or computational and mathematical tools. So friends, we discussed that before using computational tools, we must decide the quality of our knowledge. And most of the time, quality of knowledge is substandard. That is, knowledge cannot be perfect. and which type of imperfection, determination of that is very important in order to solve the problem computationally properly. Now we come to the next one, appropriate type of reasoning. Until unless we know which type of reasoning is required in solving a particular problem, we again may commit mistakes. Friends, there are large number of reasoning types, including logical, analogical, geometrical, statistical, combinatorial. However, in view of the paucity of time, we just mentioned the logical reasoning, of which the following are major subtypes. Three major types of reasoning which are generally used in scientific and technological pursuits. One is deductive, which is generally used for mathematical sciences; inductive, suitable for natural and social sciences; and abductive, appropriate for diagnostic purpose. I explained the last one that when we go to the doctor after falling ill, neither we nor the doctor knows what is the disease, but we know the symptoms. So the main thing is the disease. Disease gives rise to symptoms, but we don't know the disease. Disease is to be known. We know the symptoms. From the symptoms to know the disease, it is the reverse of deductive that way. So these three types of reasoning methodologies, and depending upon the subject matter or the problem type, we should choose the one which is most appropriate for them. Anyway, friends, deduction, we know that whenever we are given P implies Q and the antecedent, the first part, the left part is given, then we conclude the right part, that is Q. Abduction is just opposite. As I just said, P is the disease, Q is the symptom, because disease gives rise to symptoms, but we know the symptoms and we intend to find out the disease. That is, here the problem is just the opposite. And this is called abduction. Most of the doctors or diagnostic problems involve this. We know the symptoms, but not the real cause. And induction is the form of drawing statements P from the conclusion, from the given observations P1, P2, P. We have the n instances. And in scientific pursuits, most of the time, of course, the deduction is also used, but induction plays a very important role in general experimental sciences. Now we come to the major last part, some salient aspects of academic computational linkages. This is divided into three parts. First of all, three phases or stages of IT revolution. The second part is cyber academic linkages. And the last part is subtle contribution of IT revolution to academics. Friends, the cyber revolution, which started around the middle of 20th century, gradually evolved through three stages. First stage is computerization, leading to computer revolution. That is solution by machine of problems involving intellectual, not just manual capabilities. I clarify, earlier also the machines were there, but they replaced only the human manual work. Computer, for the first time, is replacing the intellectual aspects of problem solving. The second stage, which started around 1990, late 1990s, is informationization. This is my own word. It is not used. Informization, leading to information revolution, connecting human beings on massive scale. Of course, telephone, etc. were there. But once around 1990s or so, now almost everybody is connected with everybody without being consciously connected to each other. And the third stage, which is almost started recently, again the word sensorization is my own word. sensorization leading to connectivity revolution, connecting human beings and non-living entities on massive scale. Here the third part differentiates from the second in the sense in the informationization or second stage only the human beings were massively connected. But now everything on earth and beyond can be connected. And this is the third part, the sensorization revolution is still in the making. I go little bit in the details of each three just to pay our homage to those who did. First of all, very briefly, we look computerization. The roots of computerization go back to the idea of formalization. Hence, whole of computer enterprise depends on formalization. What is formalization? That first of all, you make the most elementary things explicitly their notation. For example, English alphabet ABCD has to be, and if delta is not there, you have to mention it that delta is not acceptable as a character. And once you have defined the basic elements or characters, you should tell very explicitly what are the rules of making words. You should tell very explicitly the rules for making phrases, sentences, paragraphs, etc. This is what is meant by formalization. And this idea of formalization has been conceived thousands of years back in almost all civilizations, whether it was Egyptian, Mesopotamian, Indian, Greek, Chinese. Friends, as I mentioned, computer is a formal system. Everything is explicitly defined. But we human beings are informal system. Without explicitly defining, we can interact, we can solve problems, etc. So the first step in computerization was the idea of formalization. It is a very important idea. Today it may look not very simple, but the first person or first people who thought of it really did wonderful. However, in the recorded history, credit goes to Aristotle in the form of syllogism. For example, all roses are flowers. This is a rose, therefore I'm holding a flower. In modern times, Leibniz is said to be grandfather of modern computer revolution. And he gave many of the ideas about formalization. Then friends in the middle 19th century, George Boole, Gottlieb Frege, etc. came, who also formalized human thought. What we are discussing, the foundation of computerization is formalization and who contributed to it. So friends, these are some of the people, great luminaries who made formalization. They gave the ideas of formalization and made the modern computer revolution proper. Friends, again I'm discussing what is the basis of computerization. Let us have a look for a while, though it is maybe going too elementary. But the most fundamental, or if somebody asks, what is the most fundamental concept, single concept of computer science, then it is algorithm. Everything in computer science we do is about algorithms. When we have to solve a problem, we are writing an algorithm. When we are designing a machine, it is to execute algorithm and so on and so forth. Theory of computation is what algorithms can do and cannot do. So whole of computer science revolves around algorithm. Let us have a look at this. What is its significance? What is an algorithm? Algorithm is a step-by-step finite method of solving problem. Algorithm, what is the significance of algorithm? How it distinguishes from our other methods of solving problems. The other method may be hit and trial method, which I explained briefly. For example, the equation to be solved is x squared plus x minus 6 is 0. By hit and trial, we may go on substituting values 0, 1, 2, etc. And ultimately we get the solution x is equal to 2. So friends, by hit and trial, we get the solution of this equation. But friends, replace the -6 by +6. And you'll find your hit trial method fails. And why? Because the solution is very complicated. No hit trial method may solve the problem. And here lies the significance of algorithm. There is a systematic method of solving the quadratic equation of this type. Everybody knows, find the b square plus 4ac, etc., etc. So, friends, this is how algorithm, which is a systematic method of solving problems, is really a great asset. And whole computer science, all softwares, thus constitute algorithms. Friends, you'll be surprised. Automated self-driving cars run only by a collection or a system of algorithms only, apart from the hardware and all that, sensors and all. Friends, here I have to say a few words. Any solution of a problem using computer is a solution by system of algorithm. In view of the visible power of computer, thinking that computer can solve any problem is wrong. It was proved during 1930s. And it was proved mathematically that only a very small fraction of the problems human beings encounter can be solved with a computer. Algorithmical. Whenever we say solved by computer means solved algorithmically. Most of the problems cannot be solved by computer without human intervention, that is by some system of algorithms step by step. So we must remember this. The power of computer is limited, of course, by its brute force. It may be used or it may give a semblance of applications. As Professor Mukhopadhyay in the very beginning, that AI is creating a lot of problems also side by side. Well, we come to the second stage of this revolution. Friends, information storage has been one of the basic activity even during computerization. Information storage, but information sharing was a revolution later through internet and World Wide Web. Technologies that led to informationization or information revolution. The two major parts of this, of course, there are others also. The internet is a sort of information superhighway system of roads, bridges, and tunnels. It is a technical network and infrastructure that connects all the computers and devices that are online across the world. This is it is sort of information superhighway. Being connected to the internet means devices and whoever is using them can communicate with each other. This is what is internet. And I'll say the second part, informationization. Since the middle of 20th century, with the introduction of electronic stored program mean from computers in 1940s, internet in around 60s, officially born on 1983, but in actuality, with the introduction of web by Tim Berners-Lee in 1990s, cyberspace consisting of electronically, optically represented data information actually become informationized. It was the introduction of course, the internet was earlier also, but it was the World Wide Web by Tim Berners-Lee, which connected the human beings on massive scale. Hence, we pay homage just by remembering some of the people who made the current revolution possible. Well, WWE, World Wide Web, is said to have originated with the idea of Memex, posed by Vannevar Bush in 1940 article. He wrote this article, as we may think, as a hypothetical electromagnetic device for storing all tangible intellectual assets so that these may be accessed promptly. Actually, whenever Bush played a very important role in giving grants, etc., to the various universities and other institutions which developed or brought this computer revolution, he was the chief of government for distributing of funds, etc., and a great laureate in his own right. Now, friends, we come to the third stage, which we may call sensorization, which is still going on. In this respect, the developments are only in rudimentary stage. The basic difference will be that strong sensors. What is this sensors use? Strong sensors will be deployed globally so as to capture moment-to-moment information about every entity, at least on Earth. For example, in respect of your refrigerator at home, you being anywhere outside can know its content, parameters of its safety, whether it has become warm or electricity is not being supplied properly. Similarly, for anything, say about a ship at sea, data about it will be available to the concerned through the sensors. There are three phases and fourth phase is going on. In the beginning of this, you can say IoT, also Internet of Things. First of all, information was uploaded in the cyberspace and the people were able to read it only. Later on, the people, anybody can write and read also. This was the first phase. In the second phase, you can see on the right-hand side, the sensors were used. Physical space. Now, anything, as I mentioned, of the refrigerator or the plane or anything, about the extension of the cyberspace to include physical space through various sensors, sensorization. Some significant information in physics can be automatically sensed, stored, and transmitted. Web of things can be regarded as a kind of cyber. And friends, what is the specialty? In cyber physical system, every entity and phenomena in the non-human physical world, including a man-made artifact, has its cyber dual or cyber image. That is, everything on earth will have a image in the cyberspace, electronic, optical world. The cyber dual of a tree is not merely, please read it, the cyber dual of a tree is not merely represented by its identifier, tree number, tree type, geographical location, but also includes its physiological processes, its safety and health parameters. Similarly, a ship is not merely represented by its identifier or by its dynamically changing geographical position, but also by the movement of the people and goods within the ship and various processes about its safety. For each physical entity, the authenticity of the representation in respect of its relations, interaction, and behavior in the cyberspace in the form of cyber image is dynamically maintained through sensors, embedded systems, communication infrastructure, including the internet. So, friends, you can differentiate. Now, the health of the ship, health of the people on the ship is also known or will be known in the near future. And this is the, here, you are saying actuator. Now you can impact the physical space in this stage. Impact, that is as is happening in the case of spaceships, that any fault in the spaceship is rectified here, but it is limited case. Now it will become omnipresent. Almost every instrument on the earth, it is not the special case of spaceships only, but everything on earth can be remedied by these actuators. However, I again recall Professor Mukhopadhyay's warning that each advantage is so apparently advantageous may have the or harbinger of most dangerous situations also, but that may be the topic of another talk. Friends, some of the consequences of the sensorization, the goods being delivered by robots, and here the receptionist on the left hand, and a robot is taking care of an elderly in Japan, some of the consequences and the parameters of this lady on the right are being transferred to the concerned doctors, nurses, etc. also. So sensorization has started playing a very important role. Friends, we are coming to the last slides, few slides, cyber academic research linkages, because that is the main topic. Next, we have a cursory glance how the cyber revolution is transforming the research and academics in general. Friends, as we have three phases of revolution, similarly, there are three aspects of cyber academic research linkages. They may be called digital, for example, digital humanities, for which Professor Hoda has asked me to deliver a lecture in the near future, and digital enterprise, digital economy, digital sociology. The second aspect of the linkages is computational. Computational humanities, computational economics, computational sociology. Informatics based. This is the third aspect of cyber resources for academic purposes. And these are security informatics, social informatics, medical informatics. How these adjectives, digital, computation, and informatics, differ from each other, we illustrate through some simple examples. The differences between the three terms, digital, computational, and informatics, used as prefix, suffix, may be illustrated through the following example in context of, I'll take two examples. One is that of money, that is, I'll explain the difference. What is the difference between digital money, computational aspects of money, and informatics aspect of money? And similarly, I'll explain the difference between digital sociology, computational sociology, and sociological informatics. Friends, we are discussing the difference between the three terms digital, computational, and informatics. Example of money to differentiate: the money available through an electronic wallet like Bhim is digital money. You can't touch it because money is transferred in your account from another place. The processes that go inside the computers and internet, which allow the transferring money from one account to other, are computational aspects of monetary aspect. And the large number of accounts that keep record of the electronic digital money available to different persons or organizations are stored in large databases. A discipline which allows us to create such large databases so that the accounts are created, updated, maintained properly, efficiently is called informatics. Friends, I take another example, an academic discipline, sociology. Well, friends, digital sociology is a sub-discipline of academic field of sociology. It focuses on understanding the use of digital media as a part of everyday life. That is that aspect of society in which the use of digital media is highlighted. That aspect of sociology is called digital sociology. Computational sociology is a branch of sociology that uses computationally intensive methods to analyze and model the social behavior or social phenomena. This is something different. And lastly, using computer simulation, artificial intelligence, complex statistical methods, analytical approaches like social network analysis, computational sociology develops and tests theories of complex social processes through bottom-up modeling of social interactions. So this is computational sociology, which is different from the aspect of society which uses how it uses digital media. An example of sociology, social informatics, is the study of information and communication tools in cultural and institutional context. So friends, I tried to differentiate the three terms. Finally, we are coming subtle contributions of IT computational revolution to academics. Friends, raising a very good question is also very important and rather in sometimes more important than solving problems. And this IT revolution has set many questions, challenging questions before the intellectuals. And this is really a great contribution for the academics by the computer revolution. New type of academic questions are required to be answered by the intellectuals. In view of the artificial intelligence and artificial life, scholars have been challenged with either new philosophical questions or old questions with new perspective. What is intelligence? Earlier it was thought that only human beings have intelligence. But now machine can surpass in many of the aspects which we call intelligent. Therefore, the scholars have to rethink the concept of intelligence. Similarly, we have artificial life. Now, those entities created through virtual life may behave almost like living entities or so-called living entities in our opinion. But now it requires a new definition. What can be known and what cannot be known through epistemology, it is a new challenge to epistemologists. What is identity of person? When gradually one by one parts of the person are replaced, after how much replacements one becomes a different person. These are just a tip of the iceberg of the new questions or new academic challenges for the intellectuals. Further, creating an environment which IT has done for such is no less a contribution, as I have already said. Other academic challenges due to IT revolution, new legal questions, is in the case of damage by software or by self-driving vehicle, who is responsible? The designer, the person who owns the vehicle, etc. Lot of new legal questions have arisen because of the cyber revolution. Similarly, new type of questions and challenges in almost every academic discipline. How to bridge gap between two distinct intelligences. Friends, now this is also a challenge. I have already said that many of the problems, human problems, arise because of the different styles of thinking, human style of thinking and machine style of thinking. How to create a bridge so that it is the communication between human and machine becomes natural or easy. So these are also academic challenges for academic community. So, though it is implicitly said in the previous, yet we mention it explicitly. A subtle contribution of IT revolutions to academics in order to solve a problem using a machine for execution, we have also to think how a machine will do it. Thus, for this purpose, we have to think as to two different intellectual levels. Friends, as I mentioned earlier also, first of all, we solve a problem when particularly very difficult problems are solved by software engineers. It compels them to think at two levels. First of all, we solve the problem as human beings. And then we will have to take into consideration special characteristic of machine. How this has to be translated. And by this way, our intellectual capabilities have been enhanced or challenged to be enhanced. That is, we have to think at a meta level. Doing so develops our intellectual capability to still higher level that enables us to think like a machine, which has not happened earlier. Friends, I have mentioned earlier, but still as a summary in the last two slides, availability of knowledge, we have already for the academic at the click of a button, Wikipedia, World Wide Web, etc., universal philanthropy, etc. It is World Wide Web and Wikipedia, etc., have been made possible, serving the whole humanity only because of this revolution. Large subject-specific databases, powerful tools for creating, searching, accessing knowledge are available now. Developing e-learning tools, techniques, and appropriate have been possible because of this IT revolution. Numerous initiatives in respect of massive open line online, well, actually, Coursera, Khan Academy, etc., they have made the academic resources available to even far where there are no roads, but the courses may be available and very cheaply. So these are some of the contributions. Finally, friends, I conclude. Computing and communication resources provide immense facilities for academic and research purposes. Of course, the electronic speed and minuscule storage requirements play a significant role in facilitating this. But if these resources are not utilized appropriately, some aspects of which are discussed here, these very resources may not only lead to incorrect and undesirable conclusions, but may prove to be quite disastrous. Friends, these are some of the references, and this is, well, friends, I'm really thankful for your patient listening and all that. And now some questions, if are there, please ask me the questions.
Thank you so much, sir. It was a wonderful session. Attendees have already appreciated it. Yes, there are a few questions, sir. I'll now take them up with your permission.
Dr. Ritika, can you help me in getting rid of these slides? Can I cancel it out?
Yes, sir. At the top, there will be an option. At the top of your desktop, there is an option, stop sharing.
Oh, just 1 minute, madam.
Yes, sir. Just click on it.
Where this is the slide is visible.
At the top of the slide, if you take your mouse, there is an option, stop sharing.
Anyway, you are visible now. So
Okay,
I think my problem is solved. Start video and all that. Okay, please ask the questions.
Yes, sir. So the first question we have, computational speed and problem solving has advanced to past human expertise. In such a scenario, does the existence of mankind face any challenges due to powerful computational power? Should I repeat, sir?
If you and I have told I am a bit hard, but I am able to. Your voice is loud enough, but a bit slowly, please.
Yes, sir. I'll repeat the question. It says computational speed and problem solving has advanced in present times to past human expertise. In this scenario, does the existence of mankind face any challenges due to powerful computational power?
Yeah, and Dr. Ritika, I have understood, and really the question is very interesting. But what I have to say is that already apprehensions are there. But whenever new technologies came earlier, such apprehensions were there also. But this time, because our final asset is intellectual, and therefore the danger seems to be very correct. Well, there are many scholars who think it will be good for humanity. That is, the humanity is being deprived of the pain and many other things. But there are other scholars who think that this may not be good for the humanity, and ultimately humanity may be made subservient to the machine. So this is a question of vast significance being discussed among the intellectuals at the top level. No clear-cut answer is there. My own apprehension is there that the nature has given finite time to everything on earth. And I think we have played our role. In this respect, I'll quote a book. There is a book, Hitchhiker's Guide to Artificial Intelligence. It was written in 1985. I repeat the name of the book, Hitchhiker's Guide for Artificial Intelligence by Forsyth and Naylor, Naylor. And on page 249, they mention that humanity has opened two Pandora's boxes. One is genetic engineering, and the other is knowledge engineering. We don't know what are the future implications of these two technologies, namely genetic engineering and knowledge engineering. But it is sure that these two technologies have sown the seed of our successors to be replaced by our successors. So, madam, and the friend who has asked this question, definitely their real apprehension. And I think there is some sort of spiritual educational aspect is required where we must pay attention to, where the question should be decided not on the basis of efficiency or gains, but on the basis of long-term human welfare. The situation is going from bad to worse in the sense that only 6 mega corporations, Google, Alphabet, and others, Microsoft, WhatsApp, they have captured almost more than 90% of the business. So what I mean to say, already the common man has started losing battle to those who acquired the technology, and a day may come when the technology may even capture those owners of the technology. So this is my feeling that the situation, as I mentioned, Naylor and Forsyth, the seed of our successors is already sown. Any other
Absolutely.
question?
Absolutely, sir. Very rightly said. And I would say you have given such a beautiful answer that it has even answered the other
Thank you.
questions that people had asked regarding challenges. I would now request Professor M.N. Huda, sir, to kindly present a certificate to Professor Manohar Lal as a simple tokens of remembrance for this wonderfully knowledgeable session today.
Thank you. Thank you. Thank you.
Absolutely fantastic and outstanding session, sir. And at the end, the way you have concluded reminds us that in whichever way we follow the race of the technology, but we must understand that we keep controlling the technology. We should not allow the technology to control us. However, I have been strongly advocating that in today's time, one computer is sufficient of doing the job of maybe infinite number of people. But even infinite number of computers put together is not capable of doing the job of one extraordinary person. That also you have beautifully explained during the course of explaining the common sense. So thank you so much, sir. Will not tax you more.
Again, I thank you all for giving me this
This
opportunity
certificate
of
is
interacting with all of you. I'm really grateful for the opportunity.
it's our privilege. And this certificate is not for the purpose of certification,
Yeah.
only for the purpose of remembrance
It
that
has
we have been
a lot of value for me,
for
great
an
value
outstanding
for me.
webinar, and look
Your
forward to
sentiments are
other webinars
attached
we
to
will
it.
announce.
Thank you very much.
Thank you
Okay.
so much, sir. Thank you so much.
So, should I take leave, Dr. Ritika?
Oh,
or-
yes. Yes, sir. Yes, sir.
Thank you so much, sir. Thank you so much for this wonderful session. And we look forward to more wonderful sessions in the near future.
It will be a privilege for me. Thank you. Okay.
Thank you, sir.
Thank you.